So we learned how to do substitution, and we did that on a few cases where we just had like regular system of linear equations, and it came out to one solution. But we know graphically that if we have, say, two parallel lines like this, then there's going to be no solution because they never meet. So what happens during substitution then? Like, does the world just blow up, or do you like open up a wormhole, or I don't know. Let's find out. So let's pick two parallel lines. How about this y equals, that looks like x plus 1. Then this looks like y equals x minus 2, maybe. So these are two parallel lines, and they have no solution. There's no number that when you add one, it'll be the same as when you subtract 2 from it. What happens if we try to solve this by substitution? So substitution, let's just do, since we've got y here, let's just say that x minus 2, plug in this expression for that y there, x minus 2 equals x plus 1. And let's try to solve for x. So let's minus x from both sides, and then we get negative 2 equals 1. And uh-oh, that doesn't make sense. Negative 2 doesn't equal 1. So let's, that just doesn't make sense. So there's no solution. There's no x that you can plug in that'll make negative 2 equal to 1. X's are powerful, but not like powerful enough to change the fundamental laws of math here. Let's try another case. We also saw another case that when two lines are actually equal to each other, then the parallel and the same line, then they have like infinite solutions because they are the same line. Any line that's on itself will be on itself. Yeah. So let's take line. Yeah. Let's just keep y equals x plus 1. So we've got this line, y equals x plus 1, and then let's make another line that is equal to y equals x plus 1. We'll call it 2y equals 2x plus 2. We're just multiplying everything by 2. If you divide it by 2, you get right back to this line, so the same lines. What if we try to substitute this y into that y? Well, we get 2 times x plus 1. We're putting the x plus 1 in for that y there. 2 times x plus 1 equals 2x plus 2. 2x plus 2 equals 2x plus 2. If we try to like solve here, we subtract 2x from both sides, we get 2 equals 2. Yeah, that's true. There is no x that we can, well, any x that we plug in, this statement will be true. So it doesn't matter what we choose for like x, it's always going to come out to true. All real numbers is the solution, or it's usually assumed that you're working the real numbers, so you can just say like any number. Yeah, so those are two cases. So takeaway from this: if you do substitution and you get to something weird like this, with a statement that just is not true, then that is no solution. If you get to a statement that is true, then any number. And if you get to something normal, like, I don't know, like x equals 1, then you just go back and plug it in for y, see what it is. Tangent. It's kind of interesting to think about what might happen if 1 were equal to negative 2. Like in that case, then 1 squared would be equal to negative 2 squared be equal to 4. So like not only would 1 equal to negative 2, but also, well, 1 squared is 1. So also 4 would have to be equal to 1. So actually 4 would be equal to negative 2 also. just some weird food for thought.